Hello, good day to all my Form 4 students. Today we are here to continue on our lesson video on chapter 7, rate of reaction, and we are going to continue on part 3 of this chapter. And today for part 3 and the next upcoming part 4, teacher going to concentrate on the 4 factors affecting rate of reaction. And today in part 3, I am going to concentrate on factors that affect rate of reaction and 2 factors which are size of solid reactant and concentration of solution. So these are the 2 factors that I'm going to concentrate for part 3 video. Part 4 teacher will do on temperature and catalyst. So let's start. Okay, now so let's look at factors that affect the rate of reaction. So rate of reaction, in our previous video teacher have explained to you what is the meaning of rate of reaction, how to calculate from a graph or from a table. Okay, average rate of reaction and rate of reaction at the given time. Okay, so that was our main focus on part 1 and part 2. So now in part 3 we are going to look at 2 important factors which are size of solid reactant and concentration of solution. So one thing I would like you to understand is the reactant. Okay, so the reactant here for rate of reaction, the reactants are important as well as product too. But the reactant will determine how fast a reaction can happen, whether the rate of reaction is going to be higher or lower. So in order to increase or decrease, okay, the rate of reaction, we can manipulate the 4 factors which are size of solid reactant, concentration, temperature and catalyst. So today we concentrate on these 2 factors. Now, one thing I would like to understand, what I would like you to understand is size of solid. Now, can you see solid? So this is the main thing I want you to know. This means that at least one of the reactant must be solid in order for you to effect the rate of reaction using this factor. For instance, I've given you one example where magnesium, reactive metal magnesium, reacts with hydrochloric acid to produce gas, hydrogen gas, and a salt called magnesium chloride. And here the observable and the measurable changes, like what I have explained before, the observable and the measurable changes for this experiment is the volume of hydrogen gas. Now, let's look at how does size of solid reactant will affect the rate of reaction. Now, teacher, I am going to repeat this experiment using these 2 conditions, where first condition I use magnesium in a form of ribbon or chips. Okay, and second I am going to use magnesium powder. Okay, so magnesium powder. So the constant variable here is, can you see that the mass of the magnesium is same? Okay, so mass of magnesium is same. Now, what happens is, first thing I would like you to understand. So rather than chips, I prefer to use the word ribbon, magnesium ribbon. Sorry for that, ribbon. Okay, so one thing I would like you to understand is, let's go to magnesium ribbon, the surface area. You must understand why a certain factor affects a certain rate of reaction. Okay, and let's go to magnesium powder. Okay, so magnesium powder, just imagine this is magnesium powder and the surface area of this magnesium ribbon is 1 cm times 5 cm. So the surface area for this magnesium ribbon is 5 cm square. Okay, so I hope you can understand this. So this is technically, teacher just explaining technically. Now let's go to magnesium powder. Okay, just say this each magnesium powder is 0.01 cm times 0.01 cm. Okay, so you will get 1 times 10 to the power of -4 cm square as a surface area. So when you look at the surface area of each of these magnesium powder, of course, the magnesium ribbon looks like it is winning. Okay, so I hope you can understand. So if you compare the surface area of magnesium ribbon and surface area of one powder, okay, of one powder, okay, of the magnesium, you will find that of course the surface area of magnesium ribbon wins. But when teacher use the word total surface area, okay, so when we come to the total surface area, just say so total surface area of ribbon is 5 cm square. But if one powder is this much, but since it's powder, just say we have 1 to the power of 6 cm. Okay, so just say we have 1 to the power of 6, not cm, sorry, 1 to the power of 6 powder. Because it's powder, so it is applicable, correct or not? So because just say we have this much of powder, so how much will be the total surface area for powder? Okay, so total surface area for powder will be 1 times 10 to the power of negative 4 times 1 times 10 to the power of 6 cm square. Okay, so I hope you watch this video again and again until you can understand how teacher explain the surface area. Okay, now let's go to, that means that the total surface area for powder is 1 times 10 to the power of 2, which is 100 cm square. So can you see this? The total surface area, again teacher repeat, surface area for magnesium ribbon is 5 cm square. Surface area of one powder, just one, in Malay they call it butir. Okay, so one powder is said to be 1 times 10 to the power of negative 4 cm square. Now, of course, when you look at just surface area of one powder versus surface area of one magnesium ribbon, of course, magnesium ribbon wins. But when teacher use this word, total surface area, you look at ribbon, 5 cm square, and you look at powder. Because the amount, just say, the amount of powder that I managed to count is 1 times 10 to the power of 6 amount of powder particles, just say, okay, so this means that after times and everything, I get 100 cm cube. Now, hope you can understand now that the total surface, when it comes to total surface area, of course, powder wins. Okay, so surface area, when it comes to surface area, of course, the bigger solid reactant wins. But when it comes to total surface area, the smaller solid reactant wins. Why? Because they have more, okay, they have more particles. Okay, so that is how you explain, okay, size of solid reactant. Okay, now so this is how they explain size of solid reactant. Now let's go to graph. Now I hope you can understand this. Now let's go to how we interpret the graph. Okay, so now see, so since teacher already told you that the measurable and observable changes for this reaction is the volume of hydrogen gas. Okay, volume of hydrogen gas, just assume that the maximum amount of hydrogen gas collected is X. Okay, so just assume the maximum amount of hydrogen gas collected is X. So don't go worry about the maximum amount. So the maximum amount is going to be the same for both experiment A using ribbon and B using powder. But here when you look at the graph, even though both have the same height, okay, that means this shows the maximum height. So maximum height, sorry, maximum volume. Okay, hydrogen gas collected. So that's not your main worry. Now you can see the steepness of graph. That means B, which uses powder, has produced this graph, and A, experiment A using ribbon, has produced this graph. So you can see that this is less steeper, the gradient, okay, the gradient is less steeper compared to the gradient of A is less steeper compared to the gradient in B. Okay, so this shows that when, because if you watch teacher's video in part 2, you will understand that gradient is equivalent to rate of reaction. So that is the reason why you can explain this way, which is gradient of graph B higher or steeper than gradient of graph A. Okay, so this is how you can explain even in essay question. So first you explain using the gradient. Why? Because gradient alias rate of reaction. Okay, now so gradient of graph B is higher or steeper than gradient of graph A. Now you interpret, what does the gradient mean? This shows that rate of reaction in B higher. Remember, teacher told you that when coming to rate of reaction, you must use the word higher or lower. Okay, higher than rate of reaction in A. Okay, so rate of reaction in A. So, this shows that B has higher total surface area of magnesium in powder compared to magnesium ribbon in A. Okay, so I hope you can understand. So let me repeat. So gradient of graph B is higher or steeper than gradient in graph A. This shows that the gradient of graph A is less steeper compared to gradient in graph B. So now you interpret, what does the gradient mean? Gradient means the rate of reaction of B in B is higher than rate of reaction in A. Then you explain why. B has higher total surface area of magnesium in form of powder compared to magnesium ribbon in A. So this is how you can get marks for when you're explaining for essay question. Alright, so let's go to number 2, concentration. Second factor, which is concentration of solution. Now, first thing I want you to highlight is, when I am talking about size of solid reactant, that means I already told you that at least one of the reactant must be solid in order for you to manipulate this factor. Now, let's go to here. This shows that at least one of the reactant must be liquid in a form of solution. Okay, solution, in order for you to find or manipulate the concentration as one of the factor affecting the rate of reaction. Now, let's look at experiment A, experiment B, experiment C. So since I told you that concentration is one of the factor impacting the rate of reaction, you can say that, can you see that? Concentration, different concentration but same concentration. Now please remember that when a factor which affects a rate of reaction is being manipulated, only the steepness of the graph will be manipulated. This shows that if you manipulate the factor affecting rate of reaction, say like size of solid reactant, concentration or temperature or even catalyst, you must know that only this area, the steepness of the graph will be manipulated, but not the height. Okay, so now here you'll be surprised to find the height of the graph is different. Okay, so let me explain why you get different height in the graph, and you will be surprised to find that some of the graphs share the same gradient. Okay, now see, so what I want you to do is, when you are calculating the concentration, you have the molarity and also the volume given. So when you have the molarity and the volume given, you can find the amount of mole, which is using the formula mv over 1000. So teacher have already calculated for you the calculation of mole. So you can find that A has the lowest amount of mole, B has highest amount of mole, and C has somewhere in middle. The amount of mole is somewhere in middle. So this, from here you can label the graph that teacher have given you. So can you see that the graph has three different heights. So when the height is different, all I want you to know that height of the graph. Okay, so the first point is height of graph is equivalent to mole. So that means when the graph has higher the height of the graph, that means it has more product. Okay, higher the height of the graph, you can see that the mole is highest. So this shows that since B has the highest amount of mole, you can say that B produces this graph. And at the same time, can you see that B has the highest amount of mole concentration? So that is the reason why you can find that the steepness of the graph in B is the highest. Okay, so B high in height, okay, is the tallest and steepest. Okay, why? Because higher the height, because higher the mole, highest mole, amount of mole. Why it is steepest? Highest rate of reaction or concentration. Okay, so you can watch teacher's video again and again until you can understand this factor, because this is actually some of the important concepts that you have to know. Okay, so you'll be very useful when you are doing your objective questions. Alright, okay, now so B has the highest, okay, height of the graph for B is the highest. Why? Because B has the highest amount of mole. And B has the steepest graph. Can you see the gradient of the B is the steepest amongst these three? So this shows that our rate of reaction or the concentration is the highest for B. Now let's go to these two graphs. So can you see that they share the same gradient? Since they share the same gradient, it might be A and C. Can you see they have the same molarity? Since they have the same molarity, you can say that they share the same gradient. But you can find that the height of the graph is different. So, in order for you to find which belongs to which, you look at the mv over 1000, calculation of mv over 1000, which is amount of mole. So, who has the lowest height? Must be C. Can you see? Must be C. Why? Sorry. Must be A. Sorry. A. Why? Because 0.05 versus 0.01. So, here must be C. Okay. Why? Because C has almost double the height of the graph of A. Okay. So, this is how you determine the height of the graph when it comes to concentration. So when teacher explaining about the factors, about the science of solid reactant, it was just at one go. But when you are talking about the concentration of the reactant, concentration of the reactant in a form of solution, you have to be very careful. Why? Because it involves the height of the graph, where height of the graph is affected by the mv over 1000 of the solution, which is the mole of the solution, and the steepness of the graph is affected by the concentration of the solution used. So the key point that you need to do is height of the graph is equivalent to the mole used. Now, why concentration affects the rate of reaction? Why? Because higher the concentration, more particles can react. Okay, so this shows that more particles, meaning for instance, higher the concentration of hydrochloric acid, it has more hydrogen ion that can react with magnesium. So higher the concentration, more particles can react. So rate of reaction will be higher or graph will be steeper. The gradient of the graph, okay, so let me, the gradient of the graph of graph will be steeper. Okay, so when the gradient of the graph becomes steeper, of course rate of reaction becomes higher. Alright, okay, so this is how we explain factors affecting rate of reaction for science of solid reactant. In order for you to manipulate this factor, you must have, okay, you must have at least one reactant which is solid, and in order for you to manipulate concentration as one of the factor affecting rate of reaction, make sure one of the reactant is in a form of solid solution, solution. So this is how you compare, okay, your factor affecting rate of reaction. So in our next video, teacher will discuss regarding the temperature and also the catalyst, which are also factors affecting the rate of reaction. Okay, so till now, thank you for watching teacher's video. See you all in part 4.